Hello everyone, this is Himabindu from the Department of CSIT. So today in this video, I would like to explain the non-deterministic finite automata construction and with the examples. So here let's move to the slides. So what is meant by non-determinism? So it is having the two characteristics. So what are those two characteristics we'll see. So the non-deterministic finite automata is a variant of finite automata with two characteristics. So before going to the characteristics, so finite automata we know that in the previous videos we discussed that finite automata is having two types. One is with output and without output. So in that without output we are discussing NFA, DFA and epsilon NFA. And here with output it is having two methods, Moore, Mille. So here the finite automata is having the two methods. One is a finite automata with output and without output. In that one we are now discussing about the NFA, non-deterministic finite automata. So in the non-deterministic finite automata it is having the two characteristics. One is the epsilon transition and second one is the non-determinism. So epsilon transition is nothing but the state transition can be made without any reading a symbol. So here reading a symbol in the sense we have how many inputs for the word or language. For every input it is going to the one more state and it is moving to one state to another state with the input symbols. So here non-transition, this epsilon transition is nothing but without any input symbol it is reaching the next state. So that is the epsilon transition. And second one is a non-determinism. So here non-determinism is nothing but with zero or more than one possible value may exist for the state transition. So either we have any one single input or multiple inputs, we can move to the state transition. So that is a non-determinism. And what are the definitions? What is the definition of non-deterministic finite automata? As we already know that the DFA is having the phi tuple. The same thing here, that the NFA is also having the phi tuple. For this, what are the phi tuple contains? The phi tuple is nothing but it is having the Q and sigma, delta and Q naught and F. Let's discuss about this phi tuple. So in this one, the Q is nothing but it is a finite set of states, and this transition epsilon is nothing but input symbols. And next transition delta is equal to transition function. So here we are comparing with the NFA and DFA. The transition function is different here. The Q cross sigma leads to the 2 power Q here, and initial state and final states. So here the final state is not only a single final state, it is having the multiple. It is a subset of finite set of states. That is nothing but the finite set of state is multiple, having how many states in the Q. It is a combination or subset of the Q states, the final state. And next, and how to use an NFA. So where we have to use this one and how we can use the NFA construction. So here the input what we are giving is the word. So word is nothing but it is a combinations of 1, 0, 1. We'll take just binary numbers. So it is a combination of zeros and ones. If it is a string, input string, for this one we have to construct a NFA, and we have to check whether the string is accepted by the NFA or not. And for input is like this, the input is the W, it is having the binary numbers 0 and 1. And question is W acceptable by NFA? So if the string where we are writing this string, whether this string is accepted by the constructed NFA or not, we have to check with the steps. So what are the steps for this one, the acceptability, we first step is start at the status state. So as usual for NFA or DFA, we have to start with the status states, that is a Q naught. We are initializing the state with the Q naught. And how to initialize in the sense with the arrow mark and Q naught. We are taking the Q naught as an initial state. For every input symbol in the sequence W, so here this is the W. In this one, how many sequence symbols are nothing but 0, 1. So for every input symbol, whether it is going to which states, we have to, this is just an example, whether it is going to how many states for this input symbol, we have to check and determine all the possible next states from all current states. So here we have to determine all possible next states like this. So this is an example, like it is 0 or 1, 0 or it is going either the next state with the input symbol 0, or it is a next state with the input symbol 1, it is reaching the next state. So given the current input symbol in the W and transition function, if after all symbols in W are consumed, if here the 101, so 101, here 10, we have to go to the another state and next Q3. Like this. Finally we read the word 101 with this one. So here it is reaching the final state. So this NFA or this NFA is accepted by this string. So like this, we have to use the NFA for the acceptability of the strings. And next, so we can construct a NFA for the strings like a string containing 0, 1. So here is we have taken a simple example. So first step, what we have to do for the construction of NFA, in the sense we have to initialize this one. So initializing this NFA, in the sense we have to initialize this states with the arrow symbol. Q naught, we are taking the initial state, and after that the string containing 0, 1. So W is here nothing but the string contains 0, 1. So the string contains 0, 1, in the sense here 0, 1, it should reach the final state. So minimum length is here 2, and for this one we have to add one more state, that one 3. So here this leads to the Q. So how many states we require for the NFA construction? For this particular the string containing 0, 1, in the sense 3 states we require. So finally 0, 1 should reach the final state. So final state it is reaching. So for this one already we initiated with the Q naught, and one more 2 states we have to add for this add for the string 0, 1. So here and here 0, 1, it is reaching the final state. There is no limitation for this one. It has to be starts with 0 or 1. So that's why we have taken this self loop. So whether it is starting with 0 or 1. So that's why we are taking this self loop 0, 1. So this means that this string 0, 1 which contains 0, or I'll differentiate with the 2 input symbols 0, 1, and 1, 0, 1 and 0, 1, 0, 1. Sorry, 0, 1 is common. So 0, 1. Like this, we have to start the starting of the input symbol should be 0 or 1. So there is no limitation. The starting should be like this. So that's why we have taken the 2 input symbol for the starting state, and 0, 1 it should reach the final state. And there is no limitation that the final state should be also ends with only 0, 1. So here the string, it is not 0, 1. It should starts with. So it is starts 0, 1 in the middle, where it starts with 0 or 1, or ends with 0 or 1. So this ends with 0 or 1, in the sense the final state should have the self loop like this 0, 1. So that is the final state. So there is no limitation, sir, so that 0 comma 1 only it is having the 0 input. Starting state should be 0 comma 1 and ending state should be 0 comma 1. So that like this we have to construct a NFA for the given input string. It is the string contains only 0 1. There is no limitation of starting and ending. So that's why we have taken the two input. How many input symbols we have in the diagram in the word in the sense the string, we have to mention all the input symbol. There is no limitation. So here for this one we can also construct a transition table. For this one, let's how to construct a transition table. So here we are mentioning the phi tuple. The q is equal to how many states we have. So q how we have three states, in the sense the minimum length of the word plus one we have to add for the minimum length. So that's why it is a 3. And input symbols, how many input symbol, in the sense 0 comma 1, so it is only having the two input symbols. And the starting state is always q0 and the final state is q2. Based on the transition functions, the final state should be subset or a single set. And the transition table for this one, let's take how many states we have for this one. How many states, in the sense 3 states for every input symbol. So q0 to 0, it is having the input symbol q0 and as well as it is going to the q1. So it is a subset for the 0 input symbol. Like that, for one input symbol it is reaching only q0. So we have written the q0 here. And from the q1 state, it is for 0 there is nothing. From 1 it is going to the q2, where that word we have mentioned. And for the q2 state, so it is a 0 and 1 input symbol. So self loop, so we for the 0 and 1 input symbol it is reaching the q2 state. So this is how we have constructed a NFA for the construction NFA for the string containing 0 comma 1. And let's do the another example for the same construction of NFA. So build an NFA. Here is the build an NFA for the given language. What is that language, in the sense the W is a binary string containing with the string with 0 1 over the input alphabet 0 1. So let's what are the we'll find the steps for this one. How many steps we require for this one, as usual. So minimum length is here 0 1. So 0 1 in the sense, so it is having the minimum length 2 and we require one more. So for this one it is having the q. So how many states we require this for this construction of NFA, in the sense 3 states. Let's draw those 3 states. So always we have to initialize the state with the q0 with the arrow mark, and q1 and q2. So after this one we will find what is the final state and starting state. So here the minimum string length of the string is 2, and what is the string contains? The binary string starting with 0 1. So starting with 0 1 in the sense 0 1. So here the starting with 0 1, there is a limitation here. So it should the finally reached state. So here let's elaborate this language. The starting with 0 1. So ending, there is a no limitation of ending. So it is should end with either 0 or 1. So that should be written either 0 end with 1. So that should be written with the self loop. So ending is written like this 0 comma 1. So like this we can have to construct an NFA for the given language. So here this language contains the string, the starting state of the starting string is 0 1. So there is no limitation of ending. So that's why we have taken how many input symbols are there in this one. So 0 and 1 are the input symbols. So for every input we have to put the self loop for the final state. And let's see the one more example. And build an NFA for the following language, the binary string ending with 0 1. Same thing what we have to do, in the sense the ending with 0 1. So ending with 0 1, same thing, only 0 1 is there. So 0 1 in the sense how many states we require for the construction of NFA, in the sense minimum length plus min length plus 1. So minimum length is 2 plus 1 is 3 states. So 3 states, what are the 3 states? Let's draw. A Q0 is the starting state and Q1 is this, and so ending with 0, 1. So after 0, 1, it should reach the final state. So after 0, 1, it should reach the final state. The same thing ending with 0, 1 in the sense, though, and starting should be, there is a no limitation. So we will put 0, 1. So let's elaborate this one. Starting 0, 1, ending should be 0, 1. So, and the starting symbol is, there is no limitation. So we will write that either 0 or 1. Like this, we have to elaborate the language for the simplification of the construction of this NFA. And next example. So design an NFA with the input symbols 0, 1, accept all strings in which the third symbol from the right hand is always 0. So the third symbol from the right hand, there is a limitation like how many states, how many length of the symbols are required here, we'll see. So the third symbol from the right hand. So let's draw 1, 2 and third symbol. So the third symbol should be always right hand, should be always 0. So there is a limitation of this 0 should contains in the third symbol. So there is a no limitation of starting and ending. So there is a no limitation of starting and ending in the sense 0 or 1. We can place 0 or 1. So here also there is a no limitation of 0 or 1, 0 or 1. So the second symbol also either 0 or 1, 1, and for first symbol also either 0 or 1. So what is the minimum length of here in the sense, the here 3 plus 1. So minimum length plus 1 is equal to 4. Here the Q. So how many states required for this one in the sense, for the construction of this NFA in the sense of 4 states we require. So what are the 4 states? The first state is Q0. So first state is the Q0, and what we have written is the same thing we have written in the diagrammatic representation. So here the 0, this is the limitation. The right end from the third symbol is 0, always 0. And the first and two positions should have either 0 or 1. And the final state, it is reaching the final state. So here there is no requirement of final state. Why? Because if you add one more state to this one, this is not a third symbol. So that's why it should reach the final state. And now initially there is no limitation of 0, 1. So either it should start with a 0 or 1. So this is how we have to construct an NFA for this language. The right end is always 0 from the third position. And next example, construct an NFA for the input symbol 0, 1, in which the double 1 is followed by double 0. So here the double 1 is followed by double 0 in the sense. So here double 1. So double 1 followed by double 0. So this is the string. So here the minimum length is 4. And how many states we require for this one in the sense 4 plus minimum length plus 1, it is having a 5. And how many states we require for this construction of NFA in the sense 5 states we require for this one. So let's 1 followed by 1. So double 1s followed by double 0. So for double 1s, so like this we have three states and followed by double zeros. Let's add 2 more zeros to the same diagram. So like this, how many states we require? Finally 5 states we require. And one more thing, what is the limitation? So there is no limitation of starting and ending. So we will all add input, how many input symbols are there. We can add for the starting state and we can add for the same way as final state. So the self loop. So this is the self loop. There is a no. Let's elaborate this one for the simplification. So either this is the minimum length. So this is the limitation. So for this one, we can add 0 and 0. So both fine starting state and ending state. Same thing, we will add 1, 1, 1, double 0 and 1. And also first starting state is 1 and ending is 1. This is same, and let's same thing 0 and 1. And these are all combinations, like 4 combinations are there, like 0, 1 and 1, same thing, and 0, and here the 1, same thing, 0. Like this, how many states are there, how many possibilities are there, we can draw the elaborate the language. And next, coming to the next example. So draw an NFA for the language, all the strings over the 0, 1 that have at least 2 consecutive zeros or ones. So this is the word we have to note down. R and are different. So R in the sense from the one state. So either it is moving to next state with the input symbol 1 or next state. So this is R. And for the simplification I am drawing, and Q naught to either it is 1, comma 0. So this is and. So let's or in the sense for the same for the input symbols, for the 2 input symbols, it is reaching the 2 states, and here and in the sense it is continuously reaching the next states. So what are the consecutive zeros and what are the consecutive ones? Let's draw for this one. So here is the after construction of NFA, we have the this NFA. So here let's see this one, consecutive zeros in the sense it is. So we are, as we already discussed, this OR symbol it is having from the state Q naught is reaching the 2 states. So it is 0, either consecutive zeros and consecutive ones. So from the starting state it is reaching the consecutive zeros or consecutive ones. So with this, and here 0, 0 and 1, 1. So these are the 2 consecutive ones and these are the 2 consecutive zeros. And there is a no limitation of, it is having the starting state and starting input symbol is this one and ending input symbol is this one. That's why we have written the self loop for this one. With that, how many input symbols are there? With that, all input symbols we have to give the self loop for initial state and final state. So when there is a no limitation of the starting and ending, the starting it is also having the self loop with the input symbols, and ending with the final state is also having the input symbols. How many input symbols are there? We can have the all the input symbol with the self loop. So we can elaborate this one with this 0, 0, 0, and also this is the start state, and ending state we can represent with the 1 or 0 and 1. So this is the 2 consecutive zeros. For the same thing, we can start with 0 and 2 consecutive ones and end with 1, and the same thing consecutive ones end with 0. So like this we can elaborate for the simplification. For this one we can also check for the acceptability of the strings. So let's end with this examples, construction of NFA with the examples. In coming videos, we will discuss the conversion of NFA to DFA and NFA to DFA and epsilon NFA to NFA and epsilon NFA to DFA. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.